So what is projectile motion? Projectile motion involves a projectile. And a projectile is an object that is launched into the air, moves freely after launch, and is acted on only by gravity. So, some examples of this is a ball thrown, a cannonball, and a rock dropped from a cliff. Some non-examples of projectile motion that you should be careful of to not try to use kinematic equations with or projectile motion scenarios with is a rocket with engines firing, a plane because it has lift and thrust, and anything with air resistance. So, the key idea of projectile motion is that it is two motions at the same time. What does this mean? It means that you have horizontal motion in the x direction, and you have vertical motion in the y direction. And this motion simultaneously happens. But the important part is they don't affect each other. They're independent of each other. And this is a very key idea that is in physics, because the vertical and the horizontal motions, they are in different directions. And this also will apply later when you study forces and free body diagrams. These motions, they're considered separate from each other and analyzed separately. So, we can draw this projectile motion like this. That will be your height. This will be your range. This is the peak of your trajectory, and you will have components like this. Now, what are some physics assumptions? So, some conditions of projectile motion are that you have a constant acceleration. Also, that gravity acts downward only. In addition, your acceleration in the horizontal direction is going to be equal to 0. And your vertical acceleration is going to be equal to -g. Again, our only our only force is gravity. So that is why you say AX horizontal is going to be 0 and AY is going to be negative G. Or it can be positive G, depending on your sign choice. And that means your coordinate system, which is how you define your up and down. And this is your conventional system. But if you define your coordinate system to be different than this, then whichever direction that is in the direction of your gravity will be the sign of your gravity, of course. So these conditions are why kinematics apply. Now, let's talk more specifically about the horizontal motion. So, are there forces in the x direction? There are no forces. So A of x is equal to 0. So because of this, then we can say that velocity never changes, which can be represented as v of x is equal to v of y. So that means that kinematic equations in x simplify to just x is equal to x initial plus v initial x times t. So there is, in this kinematic equation, there will be no 1/2 at squared term, and there is no velocity change. That's because ax is going to equal to 0. And that will just cancel out. Now, on the other hand, in vertical motion, in the y direction, we have free fall, which means we only have gravity acting on in this direction. So our acceleration ay is going to equal to negative gravity, which is the universal gravity, which is the gravitational constant for gravity near Earth. So that is negative 9.8 meters per second squared. Now, we use the full kinematics equation. In the y direction, which means we have vy is equal to v initial y plus a y times t. We have y is equal to y initial plus v initial y plus 1/2 of ay t squared. And we also have that vy squared is equal to v initial squared y plus 2 acceleration y minus y initial. Now, in the upward motion, we have that velocity decreases, but we have that acceleration still points down. Now, in the downward motion, we have that velocity increases in magnitude, but our acceleration, it still points down. because it's accelerating down in the negative direction. So the object is just constantly free falling. But the acceleration is always pointing down, because the only thing we're considering in acceleration is just gravity. It's just ay is equal to negative g. So after this, let's discuss launching at an angle. Now, when something is launched at an angle, this means that the initial velocity must be split. So what does this mean? Well, again, we can draw a simple kinematic launch. So at an angle, this is our range, which will represent as r. This will be our height. Now, we can break up a point of motion when something is going up. It is going up when you move, you're moving in both the x direction and the y direction. So you can break up this v initial into cosine theta and v initial sine theta, because cosine theta will be similar to, it's just x, and then sine theta will be our y. So that is our respective x and y directions. But together, when you add these vectors together, that will give you the resultant vector, which is just v initial. Now, we can write that as v initial x is equal to v initial cosine theta, and v initial y is equal to v initial sine theta. So these are treated as separate cake kinematics problems. Now, some golden rules that you should remember when you're dealing with these problems are that the time is the same in x and y. It's intuitive, but it's something that a lot of people forget. And remember, when you're moving forward, you move forward in both the x and y direction. So those both have to have happened within the same time interval. And that's the thing that unites them, because it happens in the same amount of time. Also, remember that velocity is not the same in x and y. It's different. And also acceleration as well. We can write that separately. Remember that your horizontal velocity never changes. And again, your vertical motion acts like free fall. Now, there are going to be 4 types of questions that you encounter. So your first type of question will be a horizontal launch. And in this horizontal launch, you will always have that v initial x is not going to be equal to 0, and v initial y is equal to 0. What you do is solve y first to find time. Then you plug time into x. Now, our second type is going to be a launch at an angle. So what you're going to do is you're going to split your velocity. Then after this, you're going to solve y to get time or height. Then you're going to use the same time in x. Now for your third type, you're going to be solving for the range. And your range is the horizontal distance where your projectile lands. So that's your horizontal distance. In algebra, you may know the range as the possible y values, but range is opposite. So here, range is the horizontal distance that you launch it from. This is your range. And your landing condition is going to be y is equal to y initial, which means that you have your height is going to equal to your initial height. And then you find your time from y, and then you plug it into x. Now, the fourth type of problem you'll encounter are maximum height problems. Now here, you can write that at max height, Vy is equal to 0. And the reason is